If I want to connect a button to my computer, I need at least one wire going into the computer as input. So if I want to connect 8 buttons, I might need 8 wires. And that's a lot of wires. I really don't want to use so many wires to connect to my computer as input. Wouldn't it be nice if I could just use one wire as input to my computer and it would tell me what the values of all the 8 buttons are? With a multiplexer, you can do exactly that. So this right here is a multiplexer, and this particular multiplexer lets me convert 8 input lines into one input line. So I've already prepared a circuit, and if I connect the multiplexer, everything should start working. Okay, so everything's connected and you should be able to see all the buttons. If I press this button, my computer registers that the button is being pressed. I could press another button and my computer would also register it being pressed. And in fact, I could press both of them at the same time. I could press a different button. And my computer always knows which button is being pressed. There's only one input line connected to my computer. And thanks to the multiplexer, it knows which button is being pressed. These are the wires connected to my computer. These two are power supplies and they don't really have to come from my computer. This black wire is the input line I was talking about. And these 3 wires are something called selection lines, which I will explain later in the video. The basic idea behind a multiplexer is that you can make multiple input lines into one input line. So you don't have to worry about how many wires you're connecting. This box over here represents my multiplexer. It has 8 input lines, as you can see, from I0 all the way to I7, one output line, and it also has these 3 selection lines. At any time, the multiplexer connects one of its input lines to its output line. The selection lines help decide which input line is connected to the output. This truth table represents how the multiplexer decides which input line it should output. So if the selection lines were all set to be 0, then the output line is I0. So whatever the value of I0 will be the output of the multiplexer. If, for example, S2 was 0, S1 is 1, and S0 is 1, then the output of the multiplexer will be I3. So this truth table over here describes everything. On the example, I connected the output of my multiplexer to my computer as an input. And I'd also connected these selection lines to my computer. So the computer could decide what the values of the selection lines were. What my computer did was it continuously kept switching the values of the selection lines, and therefore it was reading all the inputs one after the other. And it did this switching about once every 50 milliseconds or something. So every 50 milliseconds, it was reading one of the inputs. So first it reads I0, then 50 milliseconds later it reads I1, and so on. So that way, if I press a button, it knows almost immediately which button it's pressed. Sure, there'll be a slight delay, but it's still very good, as you saw by the demo.